Well, howdy there, Internet students. Mr. Hermanson again. Today we're starting 6.3D, where we're going to study some sequences, two types specifically that you will need to know about: arithmetic sequences and geometric sequences. All right, and just so you kind of have a feel for what's going to happen here, arithmetic sequences are linear, so you're looking for a linear pattern to identify it as an arithmetic sequence. And geometric sequences are exponential. So you're looking for a multiplying. All right? So that's a good hint about how you're going to go about this. In fact, when we write a rule for an arithmetic sequence, we're going to use the linear equation rule, slope-intercept form. And when we write a rule for a geometric sequence, we're going to use our exponential rule, a times b to the x. Okay, now today we're just going to focus on the arithmetic sequences. So to identify it as an arithmetic sequence, we're going to look for a common difference between the terms. All right, and then to find the next number, you can either add whatever that common difference is, or you could make the rule and then use the rule to find the answers. All right, so so you've seen this rule before. The common difference we call the slope, so how much you're adding each time. And since we're talking about consecutive numbers, like let's say I have this sequence right here. I'll just do a really simple one: 2, 4, 6, 8. This is definitely an arithmetic sequence. We're adding 2 every time, right? But if we were to make a table of values and create an equation for this, x would be our term numbers. So this is our first term, this is our second term, this is our third term, this is our fourth term. So right now we have the first 4 terms: 2, 4, 6, and 8. Okay, in order to write the equation, remember that this b part is the y-intercept, which is the 0 term. So you may have to figure out what that is. In this case, it would just be 0 because our pattern is we're going up by 2 every time. So real simply, this equation for the arithmetic sequence I just gave is 2 times x. Okay, our slope is 2. So if I want to find quickly, like maybe the 50th term, I would just do 2 times 50 to get that answer, which is 100. So the 50th term in this sequence is 100. All right, so what you want to do is look and see if you're adding the same amount every time. It can be a positive or a negative number. But so to figure that out, you're going to subtract 11 and 5, which is 6, 17 and 11, which is 6, 23 and 17, which is 6. And if you're adding the same amount every time, so you're adding 6, that is definitely an arithmetic sequence. And once you know you're adding 6, you can write the function rule. Actually, we're going to use function notation now. So to get the next term, just add another 6. So this would be 29. And then add another 6. That would be 35. And then the function rule will look like this. Remember, x is what term you are. So the first term of this sequence is 5. But since you're adding 6, that's going to be your slope. So you're going to do 6 times x. Now, if I did 6 times 1, so my first term, I actually get 6. So I am going to have to fix that. I'm going to have a y-intercept here. And the y-intercept we want is actually the 0th term. So 6 times 1 is 6, plus what number would make it equal to 5? And that would be -1, or 6x minus 1. The other way you can do that is just think about going back. So our terms go like this. Our first term is 5, our second term is 11, then we go to 17. Just go back 1 to the 0th term. And to do that, you would subtract 6 from 5, which is -1. Now, I would probably just write that as 6x minus 1 is our function rule. So now if you got kind of lazy and you wanted to know like what the 15th number is in this, you would just do 6 times 15 minus 1 to get that, which is, I think, 89. All right, so that's how you identify and write a rule. So let's let you try it. Check these out, you guys. Figure out which one of these is arithmetic by finding the common difference, and then write the rule for that one. Go ahead and give it a shot. All right, you should have picked sequence B here. Okay, and that's because you are adding 6 each time. Now, so whatever you're adding, that's going to be your slope. That's what your multiplier is. Now, if you multiply 6 times 3, or 6 times 1, I mean, because this is your first term, this is your second term, this is your third term, this is your fourth. So if you do 6 times 1, you get 6 minus 3 is 3. The way you can figure out what that term is just go back to the 0th term. So from this number right here, you would subtract 6. 3 minus 6 is negative 3. And the 0th term is your y-intercept. All right, so Justine's grandfather puts $100 in her savings account on her first birthday. So we can think of this as a sequence where on her first birthday she has 100, and then he puts 125 into the account on her next, at 150 and 175. So this is going up by 25. Okay. And we want to write a function rule for this, a sequence rule. Okay. The number that we are going up by is 25, so that number goes in front of the x. Now, in order to figure out what we're going to add to that, you have to go back to the 0th term once again. And if we go back to the 0th term, that will give us 75. And if you want to figure out how much she has on her 12th birthday now, you're just going to do 25 times 12 plus 75, which I think is 25 times 12 is $375. So on her 12th birthday, she's going to get $375. Wow, what a nice grandpa. All right. So, you guys, I'm going to let you do these. So you're going to figure out which of these is arithmetic. Okay. You're going to tell that by finding the common difference. So do 22 minus 14 is 8. 30 minus 22 is 8. 38 minus 30 is 8. And if you keep getting the same difference, you're going to say, yes, it's arithmetic. Okay. And if you say yes, find the common difference. So let's just call that D for common difference, is 8. Okay, and then you're supposed to find the next 3 terms. So you could just keep adding 8. 46 plus 8 is 54, 62, and 7. All right. You can find the next 3 terms if it's not just by finding out what the pattern is, but since this one is not, the common difference here is 20. 25 minus 5 is 20. 125 minus 20 is 100. Right there, you're going to say, nope. And then you can go on to the next one. All right, go ahead and finish those up. All right, here's your answers. How'd you do? Okay. On these, you are going to, you're going to write the expression, so the function rule. So, and the way you're going to do that is find the common difference. Okay, I see that we're adding 3 every time here, right? So I'm going to do 3 times x, and then I'm going to go back to the 0th term by subtracting 3, which will bring me back to 0, and that's what I will add on. Adding 0 is not going to change it, so I don't really need to do that. So let me pick one here that's a little more difficult. Number 11, it looks like we're adding 6 every time, right? So we're going to do 6x. Okay, and then I'm going to go back to the 0th term by subtracting 6 from 7, which would be 1, and that's going to be my y-intercept. All right, go ahead and do the other ones. All right, there's your answers for those. On these fraction ones, since the denominator is the same, you can just look at what is being added in the numerator. So we're adding 3/7 every time. All right, on these, we're going to use the expression to find the x term. So I want to know what the 10th term is, and I'm going to write it an expression to figure that out. Okay, you guys see that this one's going up by 3. So I'm going to do 3x. And I'm going to go back to that's the first term, remember, that's the second term. I want the 0th term for my y-intercept, so I'm going to do 2 minus 3, which is negative 1. I'm going to put minus 1, and then I'm going to do 3 times 10 to find the 10th term minus 1, which is 29. All right, so go ahead and do the rest of those. Remember that if you're going down, you're going to have a negative slope. Like in this one, you're going to have a negative slope. All right, so here's your answers for that. Other than that, go ahead and try the homework, and if you have any issues with it, message me, and we'll talk to you soon.